Hello and welcome to Live Coding with Gerph. No audio here, says Alan. That was interesting. Can you hear me? Am I coming out? Is this at all good? We don't know. Yeah? We have sound, yeah? You can hear me talk. Well, that's good. Don't know why there was no audio on the... Oh, I know why there was no audio. I pressed the mute button, didn't I? Thinking it was the mic mute button. Let me just confirm. Yeah, I pressed the wrong button, I think. How's that? I know how to work things. It's good. Right, okay. We're professional here. All professionals. Yeah. Silly. I probably left that broken last week as well. Oh well. Okay, welcome to Live Coding with Gerph. Today we are working with the Wimp Sprite Rendering. So what that means is we're handling the drawing of bitmaps specifically for icons and what will be furniture, but we're not going to worry about the furniture just yet. We're only worrying specifically about what will be there for icons. So we've started putting together some basic C interfaces here so that we can do some of the operations, and this has all been converted from the Python code that I've got. And so I'm doing this all by hand, just translating the code into C code. So the process we've gone through is, or I've gone through rather, is read the PRMs or remember how things work, sometimes remembering badly and then having to fix things later, and then implement in Python for Pyromaniac. And then I can see that it all works and I can check things are doing the right thing and that the design works. And then once I've got that working, we then switch to this phase, which is implementing it in C code. So we're not actually dealing with how the WindowManager itself, in the assembly code, deals with it. We're only doing it for the what's actually needed, and then we'll find the little corner cases and the like, and we'll fix those. That way we don't end up with a mess of C code that is not well structured, and which may or may not have been the case, but that's the idea anyway. We avoid the issue of having assembly but written in C code. So what we got so far? So far, we have a main function that does nothing. It literally does nothing at all. All that we've got is some stub routines, which are very stubby. There's not a lot we can say about that, really. So have a look here. We've got this. So have a look in this file. This file has get pixel translation, getting the sprites, getting scales, and this is all basically a Wimp Sprites. This is an object that we create. So we create one of these, and it has a reference to a sprite, to the graphics context, which we haven't actually got a graphics context yet, but we will create one, and then some actual data on pixel translations and the like. And all this is there so that we can start filling things in. And as we have a look in here, we'll see that there are a whole load of things that are stubbed. So if we have a look in palette here, it's like palette is just completely a stub there that just goes, yeah, colors, copy them, don't care. Scaling routines, we've got some very simple scaling to apply scales, and then bounding boxes, nothing particularly complicated. And we should be using muldiv on this because it's liable that the values will overflow. So that's all the process that we're going through. Yeah, so we now need to start implementing some of the code. If we have a look at the top of the file here, we'll see that there's basically some routines here that just do dummy operations, just so we can get things to compile. So no sprite rendering just yet, just dummy implementation, and that's because we're taking it from the Python code. which I haven't got a copy of lying around, so let's go and pull that up. Till projects, Riscos, Pyromaniac, the Riscos implementation. And this will all be in Windows? No? What's in Windows then? I don't know what's in that. It'll be modules, won't it? PyMods, core module, WindowManager. So we are looking at sprites, which is part of the Wimp graphics context. This thing here. So if we have a look over here, we can see there's Wimp Sprite Create and then Get Size and a few others. So all of these are routines that are in here. But if you look for the PixTrans one, because that's most likely to be the easiest one to find. So what we've got in this particular class is just a stub that says this is the base object, and then we've got a Riscos specialization here, which is derived from that, which is the operations we're doing. And as you can see, this looks, well, hopefully you can see in the very quick glance that we had, this is very similar to the get PixTrans code. Get PixTrans here, it does log 2 bit per pixels, goes and checks whether there's a palette or not, does the sprite address things. This is the bit where we do color mapping. That's the color mapping handling there. Color trans tables, getting the table size and then getting the table itself is all here, and then we go and return the values. So that's basically all that routine does. Then we got the render routine, which, as you can see, has been copied down here, which is handy because then we can just go and implement it. So now let's try implementing a bit of this, because it's not actually going to be that difficult, because all it seems to be doing is just going, are we tiling? Yes, we are. Fair enough. Actually, does this even want to... yeah. Yes, this is pretty much a very simple routine. Yeah. So there's going to be Wimp Sprite render, and it takes a Wimp Sprite T, because that's the self value, W Sprite. We've also got an X0 and a Y0, which is the lower left corner that we want to render at. And we want to know whether it's tiled or not. So is tiled. I'll try and keep the variables like the same so that we're not like getting ourselves too confused between the different implementations. I think a scaled is a scale T. Is that right? Is it scale T? Let's see. Get scale is it returns a scale T. Good. So we can just read that. Equals W Sprite to, oh no, sorry, they're not actually objects like that. Not render, get scale of the sprites. There we go. Then we want to get the pixel trans, which honestly is this, but we can't do it that way. Let's have a look at how PixTrans works. Oh, we return it in objects, so it does actually get it back that way, which is actually quite handy. Very similar then. So that's Wimp PixTrans. It's a W PixTrans because it's not a raw pixel translation table. Equals Wimp Sprite get PixTrans, passing in W Sprite. Okay, so we've now got two of those done. Plot action, we always want to use the mask. Probably, yeah, okay. So we want to get the plot action equals W PixTrans to plot action, or I'm sure that must be set somewhere. Do we have a sprite constant? Looks like it might be in there. Plot action use mask. Excellent. So there we go. That one goes straight into there. And then we've got this try and finally free things. So what we want to do here is basically call a tile routine or a render routine. So that's going to be just a sprite tile Which sprite are we rendering? We're rendering WSprite to sprite. Oh, I've missed the graphics apply clipping. So we want to do WSprite to graphics to what was I calling the Wimp graphics? Was I actually calling them graphics routines? I don't think I've got any Wimp graphics routines. Okay, well we'll call them Wimp graphics because it's nice and consistent. Apply clip. So a clipping table can have been passed through to the graphics context. Is what the idea is. We've got a graphics context that contains a clipping table, and you can say, I want it to use this, and then if nothing ever actually needs it, we never apply it to the screen. But at the point at which we're actually trying to render the sprite, we can apply it. Now, when we're rendering the sprite will be clipped to the rectangle of the icon. And then we'll plot the text as well, and the text will then call apply clip, but apply clip will do nothing because the clipping table has already been applied. And that's because the clipping table could be quite an expensive operation because it's a set of VU calls. In the future it might not be, but at the moment it's possibly an expensive one. And we should try and give that a bit of a chance to optimize there. Right, so this is this. We want to tile it at x0, y0 with a scaling table that is the scale. And scale is the thing we received. The plot action is the one that we just created, and the pixel translation is wpixtrans to pixtrans. Now, the question we've got here is, having claimed this, do we allocate the space for it ourselves? We do, so we need to have a free for this pixtrans as well. So what I'll do is, we could actually, I'll create a free pixtrans call, and we'll just do it that way. But what we can do is we can potentially cache these. But if we know where their lifetime is, that'll make it easier to do a caching system. So this is going to be free pixtrans. A lot of the time these pixel translation tables will be exactly the same, so this will be really pointless, but free the allocated pixel translation. And it also means that we could keep them allocated for there we go, for many of the different operations that we want to do. That's not going to be a Wimp Sprite, it's going to be a Wimp Pixtrans. WPixtrans. Free WPixtrans, there we go, just free it. Nothing else to do with that. Which probably means that this one here should also free it. Returns none. Whoop, that was the wrong key. Void the word decrement the usage count here if necessary in the future. Let's do that as mark it as a fix me. We can worry about that later. So there's the clipping. This we only want to do if is tiled and call into that. Otherwise, we call in. Oh, we should probably have an error point here. So, no, what's error? Because it's useful to be able to actually know what went wrong. And this one's a render. X, Y with a scale and a plot and a pixtrans. Yep, that's all exactly the same as what we had down here. And there we go. If we had a pixel translation, then free it. Oh, it could be null. That doesn't matter. That's nice and safe anyway. but we can actually do WPix trans here, because when we come to doing the caching part, that part only lives inside there, just to make it very clear. Okay, and actually we may as well return the error there, because this does pass the errors on as an exception, so let us do that. Always be useful for when we have to debug this. Okay, so this is Wimp Sprite Render. Render a given sprite to a position, possibly tiled. WSprite. Sprite we wish to render. Oops, that's also wrong. And it's not sprite either. It's WPix trans, dear me. That's the problem with having comments in like this in here. You end up having to update so much. Boom, boom, boom. Pointer to error. Oh no, if failed. Oh, it's successful, sorry, wrong way around. There we go, we've got Wimp Sprite Render, and that should actually have been called FreePix Trans as well. Right, so we probably need to populate the header file with these two routines. Oh, I think we've got a few missing here, it looks like. So let's go and just stick these in. There's also get scale, wasn't there? So this is get pix trans. We haven't even got get pix trans in here. Right. Oh, yeah, that needs to have a type in there. So I need to go over here. Get pix trans, and Wimp pix trans needs to come up here as well. And column descriptor will go in there later. All right. I've missed me semicolon. There's get pix trans. There's free pix trans. Get size. There should be a get scale as well. Here we go. Get scale. Get scale. And it also looks like, yeah, scale isn't in here either. So we, oh, because it's meant to be, it's in this scale.c here. So let's do hash include scale.h. There we go. All right, maybe that'll work. Maybe it'll compile. We're not sure. Let's give it a whirl. Viscous ammo. This is where we find I've broken everything. Because it did compile last time, so yeah. Hi, Dave. Hi, Chris. Ooh, we've got quite a few people here now. Wow. Oh, okay. That duplicate definitely. Oh, that's because I didn't delete it from the C file, did I? The definition is still here. There we are. Right. Is there anything else I need to remove? No, looks good. These are all the stubs. Oh, I'll probably need to stub up the other routines as well, won't I? Yeah, there's a couple here that are missing. So, apply clip, void. Oh dear. Wimp graphics T star graphics. Is it graphics or W graphics? What do they call it down here? It's just a. It should probably be a W graphic. No, I don't know. Yeah, we'll just call it graphics. That's fine. Yep. There we are. And what's the other one I needed? It was sprite. Oh, sprite tile and sprite render. Yeah, that's right. Oh, I don't know what the type is that. I'm sorry, Chris. Chris is like on. Hang on, you're on California time. You're crazy time zone then. This is a sprite functions thing he's got with the sprite sections. Right, so we're going to need a kernel os error star there, and it takes a Wimp Sprite called W Sprite, some coordinates, a scale T, a plot action, and a Wimp Pixtrans called Pixtrans. Right. Space in there. So that's that one, and the prototype is exactly the same for render. There we are. Now, see if we get this. Oh, hang on, I don't want to prototype. I actually want them to have an implementation and do nothing, don't I? So return null. That should be in Wimp Pixtrans T. I see now. I miss that and this one as well. Return null. No, these do nothing. Nothing particularly scary there. That's got nothing. That's got nothing. Okay. What's this actually complaining of? Yeah, I gave Pixtrans T the wrong name. Dave was outside inflating car tires. Okay, I mean, it's probably a little bit more exciting. 289, 298, sorry. Error equals that. Huh. Function argument cast. Sprite, XY, scale, plot action, Pixtrans. Oh no! That shouldn't be a... yeah, this should be a plain Pixtrans, shouldn't it? Because at this point we're not passing in a... Actually, do we have a Pixtrans T? Because that should just be a void star, really, anyway. Yeah, we'll define it in here. Type def Pixtrans T. T. Yeah, we'll void star it because we don't know what form it's going to take. Pixel. Try again. A pixel translation table as returned from $trans. Okay, did that work? Didn't actually change things to use it, did I? So this Pixtrans should just be Pixtrans there. Maybe it's not. Maybe that wasn't the parameter. It's really frustrating. It doesn't tell me the argument there. I'm sure there was a fix for that, but I haven't applied it. I know what I'm going to do. Yeah. Throw it at the 64-bit. Is it the bounds? It could be. It could be. I'm sure that the GCC will tell me what the mistake is. Expected Wimp Sprite T, but argument is a Sprite T. Oh, yeah, because it's not. Yes, we're not passing Wimp operations there. Right. Wimp graphics, yes to that one, but sprites can only deal with sprites. They're a lower level thing and shouldn't handle the others. Still got things wrong. Oh, because this, yeah. It was dumb. Both of these have got the same prototype, so I should know that they need to both be done the same way. There we go. And now the plain one. Right. So we've got some code compiling. Still not doing anything at all. As I add the stub render functions. Okay. Next thing, because I'm interested, I think I've already implemented Wimp Sprite Render and Sprite Tile when I did the WindowManager last time. I think I did, so let's have a quick look. Modules, Viscos source, sources, desktop, Wimp. So have a look in here and... Oh, really? I've got my sprite list. Oh, sprite list handling. That's for managing the different sprite areas and looking up sprites. That'll be useful. That's what we'll need for when we're handling sprite pools, which we're going to need to do pretty soon. Yeah, that's kind of fun. All right. So it's not a very complex bit of code, but at least it's something we've got. That's pointers, masks, test got tools. Oh, this is the manipulation of the tool handling, isn't it? Yeah, okay. I swear I implemented tiled rendering in C. I'm sure I did. In which case it might have been in the kernel. Nope, sprite flags is in there, and that's manipulating the sprite flags update. Set mode flags. Set mode flags from palette. Oh, this is defined when we decode what the sprite information is when we do video variables, mode variables. So you can decide that the sprite palette is actually a grayscale palette. Yeah. So it's not in there. That's frustrating. Okay. If I didn't do it in there, where else would it be? Possibly in sprite extend. Render sprite extend. I mean, this is unlikely. Ooh. I say it's unlikely, but there you go. There's a tiling algorithm. Yeah. Tile is a sprite pointer, and this is basically taking the sprite op and turning it into a tile operation instead, with a bit of code that actually works out how to do it. Fair enough. I think we'll just copy that because there's no reason not to. Although, that shouldn't even be in the Wimp. Although, do we want the Wimp to be able to work on older systems? I suppose you do. Excessive duplication of code is frustrating. Yeah, we'll copy it. We'll see what happens. I'm sure we'll be able to do something with it. Sorry, let me not pull it off the screen. So this has got some test code. Ooh, interesting. Is that? Oh yeah, because the test is on the end there, isn't it? And it calls lookup sprite, and then it goes and renders it. Yeah, that's not too bad. That's the video variables and stuff. Error flags. Oh, is that just saying it could be scoped differently? It's unused, entirely unused. Interesting. Very interesting. Don't know why we did that. Render data goes into the tile, which is the tile plotter. One instance of the tile. Yeah, it's kind of, yeah, fair enough. Right, okay, so let's lift this and we can go and put it in here and we'll just make sure it works later. So tile, it's probably got a header file as well, hasn't it? No, it hasn't. All right then. New file, tile, copy, paste. So probably we'll end up having some duplicated things in here, but that's okay as well. So hang on a second. There we go. I just disabled my my break timer was just about to go off and tell me it was time for a break, because obviously, yeah. 2006, quite a while back. That's 20 years ago. Don't you love things that are just ancient? Bounds, that'll come out of gcontext. So those are system libraries. Gcontext / gcontext h. It's actually got tile here. X and Y in the bottom left position. We aren't doing global regs here, which we had to do inside Sprite Extend. So we had the right parameters being passed around. This is the tile function, which is, it's a local function, isn't it? So it should have been static there. A scale t, that's actually fine because we've got a scale t already. Let's just include that. What else do we need? This is the rendering. If we're testing, then that's what an identity scale looks like. Regular sprite op call. If there was an error, we return it. Stop type. That's the, yeah. This is a single sprite render that we then go and pass on. Tiling sprite. That reads the sprite sizes. Muldiv does the calculation here, actually, because that muldiv calculation is actually the scale factor code in here. Scale apply. So I could use that. In fact, I probably ought to use that. Use scale apply. Oh, this is fun. This should almost certainly be getting information from the graphics system. Oh, yes, this is getting the clipping rectangle. Can we read the clipping rectangle? Does gcontext allow us to do that? Shall we ever see? Riscos. Gcontext. I presume it must. Oh no, clipping is a private. We can apply the clipping rectangle, but we can't read it. Probably would want to read that, but this will do the job for now. I'll have to rethink how that's done, I reckon. Yeah. Yeah, fine. We can work on that. So it looks like the best thing for us to do here is to start splitting out this code so it starts to be a bit more generalized. Because a lot of this looks like it's like general sprite calls. So if we can create a new sprite C file, and we can start filling out some of these functions that we've got stubbed at the moment. Sprite operations. If nadef so not riscos, sorry, sprite. So the idea is that gcontext actually be the thing we go through for most of our operations. So really we should be calling into gcontext to say these are some sprites, go and plot them. So we can hopefully get that more generalized, because this gcontext interface here, it's not fully implemented. So for example, the fill entries don't do anything at the moment, but I'd like them to be a draw operation. So it will do a draw filled region, and make these handled as regular VDU operators, which we've already got. And then I'd like a separate implementation of gcontext that is entirely dependent on, not dependent on, entirely designed to handle draw files. So you can generate a draw file using this interface, because that's trivial by comparison. It's just like dump some things into here and you're good. That's what I'd like to do. So we will need to do that. Hello, Maviondits. Hello. Can I please review it? I'm not sure what your it is there, but okay. Right, so let's start filling this with some whatever they're called, functions, implementations. Sprite header. Yep, there's the header file, and this is the C implementation. So this implementation should be doing include. We're going to need swise.h anyway. I don't know what else we're going to need. Yeah, what we'll do is we'll start pinching the dummy routines from being stubby and put them in here. Cut. Paste. So now our stubs are here. And because we've got stubs here, we need to start populating them. So get size. Read the size of a sprite in OS units. Sprite points to the sprite to read as a pointer, not a name. And and another parameter. We don't have any other parameters now. And we return. Oh, that's the description. What? I've got myself very confused here, haven't I? Got to read what you're writing. It's always useful. Sprite get size. This is returns bounding box. No, bounds as width and height. Because bounds is different to a bounding box. Bounds the width and height, and a bounding box is a position on the screen. Maybe that's not the right terms, but that's what I used. So here we're just returning it raw, but if we have a look in tile, we did this code, didn't we? Where's the tile code? Here. So this is the read the size of the sprite, and that can be scaled by the eigenfactors, and we should have the eigenfactors somewhere. Oh, we also want to apply the scale factors to it as well, but initially we start out with just this. Should I apply the eigenfactors to it? I'm not sure. What did I expect in Wimp Sprite? Get size. No, I expected that the sprite get size to literally just read the pixel size of the sprite, not the eigenfactors at all. Okay, so this is literally return things into the width and height, which is bounds.width and bounds.height. It's irritating that, because then I go and end up having to read the mode again to get the eigenfactors. Maybe that shouldn't be what we do. If height, because it would be much more efficient if we did it in one call. Okay, what I'm going to do is I'm just going to leave it like that, and then we'll refactor it later, because this is all able to be changed in the future. It's not like we're stuck with it. Bum, bum, bum. Right, so that's going to give us the bounds. Good. We don't actually need the mode, but let's just return it anyway. That goes into a uint32 mode. Oh, and this is sprite op, so we actually need to go OX200 plus that. Sprite area is OX100, and that's the sprite. This is a magic value that means just use the sprite pointer, because why wouldn't you? Now, get eigenfactors. Sprites get eigen. My tab completion just jumped me around there. Read the eigen given sprite. Not sure this is the best way of doing it. I'm feeling a bit meh about it, because it's going to end up being a bit messy. So we end up with eigens xi equals 0. We'll default to 1 1. If we don't know what it is, we'll just default to 1 1. Bounds width. No, we don't actually need to get the bounds out here, do we? We can just take those out. Just return the mode there, and then we need to call get view variables. Which is, I want to go into the tile function because it will have it in here, won't it? Here we go. Here's where it's reading stuff. That's for the screen. No, we don't actually read it for the read mode variables. Oh, read mode variables. Okay. Read mode variable for, oh, actually I could just read it for the sprite, can't I? Of course I can. Yes, you can pass a sprite pointer directly in. Let me just confirm that. So we just go look that up and go over here. Thank you. Read mode variable, screen mode, or for the current mode, but also it can be a sprite or a sprite mode. Can I pass it a sprite? I'm not sure. I think so. I thought it let me pass a sprite as well. Yeah, I'm pretty sure that's right. I'm pretty sure that's right. Yes, I'm going to say I think it's right. And the point was that I need to get a mode variable there, and I can't remember the mode variables. It's these ones here, isn't it? Mode variable x eigenfactor, and then we want to return it into R2. Ampersand eigens dot xeig. Let's try and get the code right. Yeig eig if just do that here as well. Oh, for y. And then we can return it. Do we even need this then? We don't, do we? Because we can just pass the sprite straight to it. We don't need to do that. Well, that's a bit simpler, isn't it? And then we don't even need the mode either. Sprite address is that. This is the log 2 bit per pixel. Well, that's very similar. Log 2 BPP. That, let's make it 32T. 0. And we want to read mode variable log 2 BPP into log 2 BPP. And if it wasn't set, let's make it 0, which will definitely go a bit funny. Log 2 BPP. Does it have a palette? Now, does it have a palette is a call. You know what? It's easiest to just decode it ourselves. I mean, I'm going to be lazy, but this is not. Oh. Do we have a type for sprites? We don't, do we? Sprite T is there. Where's the sprite T defined? Oh, it's there. It's defined as nothing. Good. Include sprite.h. What we'll do is we'll take that into there, we'll plonk it in here, and then we'll give it some values because we can. Right, remind me how sprite works. Or sprite op. Thank you very much. If we have a look up here, we should find the definition of a sprite. Again, this is why I regret that I didn't decide to use oslib initially. Right, so what we got then? We've got offset for next sprite, int32 t offset, and then 12 characters. You know what I'll do? I'll just copy this section here, and then we can have a look at it as we work. So there we go. Char name is 12 characters. Then we've got width in words. Horrible. uint32t width words -1. Actually, yeah, why don't we actually include the exact wording? Like this. Because then it's really clear what we've got. Oh, I've repeated the word width. Oh, and I've deleted the... no matter. There we go. Right, let's get rid of all of this to here. Lift that into here. Here we go. Right, so height in scan lines, so uint32t height -1. Keep the semicolon on. First bit. Again, these are all quite expensive because they're words rather than bytes, and they could have just been bytes. These, I'm not. I suspect there was intent to try and expand things out, and first bit is now always 0 anyway, because it on later sprites. Sprites are fun. Also, why are my eyes bleeding? Says Dave. Yes. Yeah, we don't like doing this. And a lot of this I'm not even going to need to handle. I'm going to define it anyway. Offset bitmap. And this one is uint32t offset mask. Now, amusingly, these two values are exactly the same if there isn't a mask. Not 0, they're the same. Why do that? I mean, I'm sure it made some sense, but ugh. Right, there we go. And then palette follows on here. So that means that we now have the sprite t defined. We can work with it. The sprite check is if sprite to offset bitmap equals uint8 t star, if the offset to the bitmap as a byte is the same as uint8t sprite plus size of sprite would have been better, really. False. Otherwise, true. comment in the comment. Log 2 bit per pixel. Oh dear, no. 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 I can't type. Sprite log 2 BPP. Read the depth of the sprite as log 2 bits per pixel. Does not handle modern sprite types. I always have a typo of existence, which is surprising because I know how existence is spelt. Existence. If you happen to not know what I was talking about, that is how you spell that. And I always remember that it's an ENZ, but I forget how to spell the real word. Very, very strange. Both that I can't spell it and that film. And Dave says he was just thinking of that as well. Yeah, I'm not sure if that makes us weird or whatever. It's a good film. It is a very, very strange film. I think I got that film on DVD around the same sort of time as I got The Cube as well. Not The Cube, sorry. Another film. Dave says he hasn't seen it. I enjoyed it. I thought it was quite fun. It's a little bit full of itself, but then, yeah, we like that sometimes. Does the sprite have a palette? True if there is a palette. False if not. We're going wild here. Right, tiling. Right, okay. So tiling is... Oh no. Sprite tile. Tile sprites onto the screen. Parameters. Sprite onto the sprite to x0, y0 equals bottom left. Scale equals the scale factor to use. Maybe identity. Plot action equals action for rendering. May include. We don't include pixel translations, the color trans here, do we? Interesting. May include mask, bit, plot action, pixel trans, pix trans, let's do the pixel translation table to use. Oh, or and wide pix trans. Okay, and again this is the same prototype for a render, which is render sprites, render asprite onto the screen. Oh no, pointer to error. Oh no. Boom, boom, boom. Right. So, rendering a sprite is Where's the tile function? Because the tile function in here, this is the render call. So what we should be able to do is to do os error star equals Wixos sprite op call, which is ox200 plus sprite. I don't know what the number is. I don't know what the number is. Does it tell me in here the rendering operation? Paint sprite scaled. There you go. Surely I've got that in a constant somewhere. Surely. Riscos shall thank you. Scaled in Riscos resources export. Yeah, we'll just have a look for that. Oh, recursively, please. Ooh, lots of them. No, I don't want it in Pascal, please. You can see Riscos / sprite. Well, that's a logical thing to have it in. I may be good sometimes and I may be bloody awful at others, but at least at this one I have remembered what to do. So this is put sprites 52. 52 is, I think, 34. I think that's the right value. 34 is 48 plus 4. Yes, it is. So I don't now need to do that there. And I just need to include the header. Which also means that this one here, I can use the sprite reason get. Is it get sprite info or is it just sprite info? I think it's sprite info. Include Riscos / sprite.h. There we are. There's the. Oh, I haven't included mode variables. I need to pick that out of here as well. That one there. Mode variables, sprites. There we are. Let me have a look for that. I think it's sprite info. I'm just going to have a look for that and just no, it's not that. It's not get because that reads the sprite. Okay, let's just grab the lot. Oh, there we go. 40 is read sprite size. Well, that's actually quite descriptive. And I wonder why I can't remember how to do these things sometimes. Okay. Okay, so that's going to give me a render. Oh, I haven't actually done the assignment. We don't have a sprite area. We're using the magic 256 value. We're passing in just the sprite itself, which is called sprite. The X position is that. By the time it's hit the sprite extend interface, it's already been converted into pixels. Here's plot action. Here's the scale factors, and then any pixel translation is that. We don't want to return null, we want to return the error. Okay, that should give us a scaled sprite. I mean, it probably won't compile at this point, but let's grab all these functions and put them into the header, and then we can try compiling it. And it'll, as I say, probably fail, but in fact, quite possible we may have got some loops in our header files definitions because we've dumped things in different places. That I'll just move that to the top because we don't need it right now. And we want to remove it from the header. It's not good to have it in the middle of the code. Okay, there we are. So yeah, that looks okay. Looks like we're going to need the eigenfactors, which is in, oh, it's probably in Wimp Sprite. Oh. Maybe we need a graphics. We probably do need a general types thing, don't we? Let's create a types. So pixtrans is in there, is in color trans, which makes sense. But some of these are not going to be. So this is going to be general types, as opposed to major types. So that was not very funny, I know. A sprite reading. Yep, that's a really good one. Thank you. We'll go and twiddle that. Reading. Not in that file. Not in that file. Was in one of them. There we go. Sprite reason. Thank you. Right, so this is types. So in types, we need to include things like the eigenfactors, because that's a general thing. I also probably want to move the Wimp graphics in there because we don't have a graphics class just yet. There we go. Eigenfactors is a general one. There. Okay. So now we've got some types, which means that we can start including that in the sprite header here. There's going to be a bunch of harmonization to make all this stuff work in the end anyway. But I think we're not doing too badly. So grab scale.h as well. And we also want studint.h and studbool. Meridian sprite. Bounds is in. Oh, bounds is actually defined in G context. Oh, I'm making this a big mess, aren't I? I'm just making a big mess. Well, bother. Let's see how we get on, because we can work it out later. We can work it out later. Actually, let's put that in there, because then anything that uses this will get it. Right. I want to build it. So let's do. Oh, I haven't told it to actually build the. Ooh, that didn't get very happy, did it? Pixtrans T needs a in h.sprite. Yeah, because that's in color trans constants. Which isn't actually constants anymore, but. Aha! Look at this. We got something coming out. Now we've got to tell it to build sprite. There. Really didn't work. Really didn't work. That's bounds T. Right, a bounds T. If we include sprite.h, we'll get the bounds T included from G context. Well, I thought we would. Sprite.h. Oh, no, wrong one. Sorry. That needs to include it in there, but then this probably needs to include this. In fact, we probably want types, don't we? Oh, we've got types already. Oh, okay. Try again. Oh, this is looking better. Right, C sprite. line 25. Yep, didn't define it. Did I fix the build on here so I can just do build? Oh, I might have done. Yeah, that's not right. That's Sprite. Oh, this will be much faster. Next failure. Undeclared name. Oh, right. Okay, fine. We can do that. Next one is implicit cast of pointer to exit. Error wasn't defined. That's fine. Same again. Same again. I've forgotten to define the error. That's fine. Probably means I've done it in one of the others. Tile isn't implemented yet. Oh, null isn't even defined. That's interesting. Studlib. That pulls in null, doesn't it? $51. Oh, because that should be Sprite. And again, Sprite's here. Whoa. And with that, are we actually illegal cast to char at line 100? Oh, star. Sorry, that should be a pointer. $82. Okay, it probably means SPR comma. Are there any other instances of that? No, there aren't. Build. We have a binary. Whoa. Okay. Doesn't do it. Still doesn't do anything. Still does not do any actual work. We haven't actually tested anything because, yeah. Now in my tile code over here, I had a magic bit of testing here that found the sprite in the sprite pool. Is that what we can do here? Do we actually implement Wimp extend get sprite address in Pyromaniac? I have no idea. Where's Pyro? This is Pyro. I'm not even sure we've got Wimp extend at all. Yeah, I'm not actually sure. Let's see. Okay, that's not a module. Wimp. Oh, bad implementation of icon borders. I thought I had a WindowManager module that actually did something. I thought I. Hang on. Pyro dev, Pyro's common. Help window. Oh no, command. Dot. Maybe we don't. Maybe I've actually not implemented it like that. No, I've got individual commands. Oh yes, that's why, because it's just implemented through literal swise, because I haven't really felt comfortable implementing the whole lot yet. So have a look here. We've got, this is the call that does Wimp set mode. It just goes and sets the mode. Here we are, all swise here, and none of those are extend. Right, okay. I probably need to implement extend at some point. Ah, but Wimp Sprite op get sprite. Is it get sprite or return name? Which one is the one that gets you the pointer to the sprite data? Get sprite. return name or get sprite, one of those two. That gets you the name populated, and this gets you the address of the sprite. That's the one I want. So return sprite. So that'll do the equivalent thing. That is what we will want. So let's why would you not use the Wimp Sprite op doing that one that way? Oh no, sorry, I misread that. Get sprite defines the identified space with the current contents of an area of the screen. That's not right. That's not read the address of the sprite. That's create a sprite from the screen. So that's not what I wanted. Read control block. Either way, none of these are actually going to work, are they? Because if I go back to here, these are the only ones I can use. The ones that have got the uncommented acceptable reasons. I'm not sure why get sprite is in there. I think I may have I got confused about, or maybe it isn't doing what I think it's doing. What does it say? Get sprite defines the identifier sprite with the current contents of an area of the screen. Oh yeah, that's get. That's not what I thought it was. I think that shouldn't be in there, because you can't pull stuff into the screen. All of these operations on the Wimp pool should be read-only. Select sprite. It's select sprite, isn't it? Select sprite returns you the address of the sprite. There we go. It also selects sprite for rendering through these operations, because that's the same thing to do. But yeah, select sprite is the one that I want. So I can do that. It's code number 24, but I don't know what to do it here. So if we go into our main function here, I want to get a sprite or break free. I mean, yeah, you can do either. So sprite underscore t star sprite. This is Swix os. No, sorry, Wimp Sprite op OX100 plus Sprite op Sprite reason, not readon. Select sprite. Also want to get a kernel os error out of it. Equals this. And then we give it the sprite name. Oh, so 0, because we don't have a control block in the Wimp calls. And then the sprite name, which is, what should we use? We'll use file FFF, because that was the example that was given below. And then we get that back into sprite. Right, let's go and put the registers in there. So input register 0 to 2. Output register is just number 2. There we are. If could not find sprite. Oh, we want to exit there, don't we? So exit 1. This is all this is going to do is just find a sprite in the sprite pool, which won't have anything yet. And if we just do discuss ammo, Oh, sprite T is defined in sprite.h. Oh, I can build it directly, can't I? And then I can see, okay, that sprite reason isn't there because, so that is a sprite, and this is in this file, and this one is in viscous sprite.h. There we go. Build. Right. We should probably also print a message saying found the sprite at, and then the pointer. There we are. Build. Okay. Common command. So I'll run this and this will fail. f32.wimp sprite render. Does not exist in the sprite pool, which is correct because it doesn't exist in the sprite pool. We have no sprites. So projects, Riscos, Pyromaniac, ROM resources, Wimp, sprites22, and then if we do command icon sprites, sprites22, dum dum dum, found sprite. Whee! Quite exciting, really. Yep, I'm being reminded that it's nearly break time, and given that it is break time, I think it is necessary to go and commit this since we've just got something working. Kinda. I mean, we've literally got like this many lines working, but fair enough. The rest of it should be able to be wired up. So let's add CH to there. Let's leave the sprites out because I don't want to be, oh, should I? I should probably commit some sprite. There's no reason not to. Add sprites22. It's a big file though. $500K just for that. Do I really want to add that big file, or should I just get a small one? Meh. Space is cheap. Right. More implementation. Nearly ready to start wiring up. The sprite library now has basic render and information functions. The Wimp Sprite doesn't do much, but might call to the right interfaces. The main function is the only one does anything useful, and that just finds a sprite in the pool. Let's push that, and then we can have a see what we can do in a few minutes. I'm going to go and have a break. We have 10 minutes or so break. Yeah, I know we haven't done a huge amount again, but now we get to the joy of starting to wire it up and seeing things not work, because we need to start implementing the color trans calls and some of the other interfaces that we have sort of basically stubbed, like Wimp graphics and stuff. And then we can start tearing these bits out and putting them into more sensible structures. That's the idea I'm working on anyway. All right, so 10-15 minutes worth of break. I will be back then. Oh, what's that come to? About 20 to 3. Yeah, 20 to 3. On break. Back around 2:40 ish. There we go. Right. See you in a little bit. Hello, I'm back. I'm staring at my 4 Dell monitors because apparently I can't remember which monitors I've got. Such a tiring day today. Right, so where were we up to? We were just about to try wiring some of these things up, weren't we? So we've got this which does nothing, and then all the rest that compiles but don't do anything either. What we want to be able to do is we've now got a sprite pointer. We want to turn it into a W sprite. So having got a sprite, let's now W sprite it. Wimp Sprite T W Sprite equals Wimp Sprite create what? I don't know how it works, so let's have a look. Create. Oh, very simple. We need a graphics pointer though. Okay, so we're going to need a Wimp graphics as well. I don't think we have a graphics thing yet. There's our sprite. Half size, no. False, false. Selected, false. Shaded, false. And the background color, color RGB. So what's the background color used for? It's not used for very much, is it? So let's just give it black to begin with. 000. And a selection color. This is not going to be used either, but let's make it a 96 192 96. So it's a sort of insipid green, I guess. Not amazing green, but at least it's a green. Okay. So that'll create as a sprite, but we don't yet have a graphics. So we need a Wimp graphics T star. I think we just have this defined to be a not do anything just yet. Oh, not that one. Oh, that's an object file. Don't care about those. A Wimp graphics. Come on, where's Wimp graphics live? It's one of these. Oh, so it's got some just. Oh, it's not particularly difficult data. All right, so we should write a create routine for that. So let's create a Wimp graphics. Oops. There. And we'll create a graphics operations on the screen for the Wimp. So this may actually be, it'll need a bunch of other things. So this will also include things like Wimp Sprite Pool and other bits and pieces in there as well. So we can look stuff up, but at the moment we don't really have very much. So include swize.h, and we'll pull in mode variables as well. Viscos/mode variables. Yeah. And we'll just get it to do Wimp graphics, sorry, create, just based on the screen. Wimp graphics, star. That's just graphics we're calling it here, isn't it? We're going to do it as malloc, don't we? Malloc size of star graphics, and then we'll just populate it with a few dummy values. No, we won't. We'll populate it with some real values because we can steal the code from VDUVAR, this bit. So we just do this. I don't actually want to, this is the clipping rectangle reading, but we can actually get the EIG factors here, just like this. So we do this, we can do, oh, hang on. Yeah, that's a good point. If graphics is null, return null. Always put some checks in there, and then we can do some more bits here. We don't need the bounds, but we do need these. Right. Don't want. Do I want those ones? I don't really need them, but I could actually get that as the screen size, couldn't I? That may actually be useful to have in the graphic structure. Yes, that would be useful to have in the graphic structure. So width, height, I'll call it screen width. You know, I've written these routines so many times now, I should really just move them into a library. But that is what we're trying to do here. We're trying to move some things away. I will, as I say, move things into the G context eventually. Just haven't done it yet. Screen width, screen height, X pixel, OS units for an X pixel. Oh, we probably also want the eigenfactors as well. So we'll go and, what we'll do is we'll go and move that to there. And we'll put the eigenfactors explicitly in here. There we go. And we can just update this as we need to, which is good. So what we let's give these proper actual sizes, so we're not going to be getting different sizes of data in these. That'll make it a bit easier. There we go. Okay, let's give this a whirl. We just need to populate these now. So that's actually the bounding box, which is not the bit we want either. Actually, what I'm going to do, I'm going to leave that there. Bounds T. No, I'm not. No, I'm going to get rid of it. I don't care. I'm going to go backwards and forwards on what I'm wanting to do 4 or 5 times, just because that's the way the world works. Right. So what we want is graphics to screen width equals. Now, do you remember the variables for these? Because of course they're really cunningly named. It's SCR right column and SCR B row, I believe. Bottom row. I think that's what it is. I'm really not sure. Viscous kitten, C colon, viscous H dot, mode variables. Mode specifier, mode flags, blah, blah, blah. It is X window, that's the text size, it's the other one I wanted. Well, fair enough. This should be log to BPP. This one is X wind limit and Y wind limit. 0, 1, 2, 3, 4, 5. Screen width equals view bars out 0 plus 1, because its wind limit is actually the rightmost pixel number. All of these things are -1. Shifted left by xig. I can just assign those backwards. There we go. Put them the way around. And then if that's generated an error, we should return null and just free the block. Free graphics. Wide. Just 1, sorry, but in offset 1. It's height. Graphics to eigen photos dot. So that's given us those ones, the eigenfactors. Log 2 bits per pixel needs to be assigned, so graphics to, oh, these should also be int32s as well, shouldn't they? Ensure we actually have the correct widths coming out. Log 2 bpp equals video vars out bracket 2. Oh, and that's not 4 and 5, that's 3 and 4. And then graphics to x pixel equals 1 shifted left xig. There. And the same goes for this, but for yig. Yig. No, I can't do an accent there. It will just come out looking, sounding very, very bad. And finally, we return the graphics pointer. Probably be more useful if I did that as a calloc, wouldn't it? Because then it's always assigned and empty. There we go, it's better. Right, so we've now got a Wimp Graphics create. I put this in the header file, that's really stupid. Let's go duplicate it as a C file, and then I'll go and cut the H file down. Thank you very much. That's the C file, H file, whoop, and if. No, that's not what I wanted to do. If nedef graphics, do want something here. Wimp graphics. Create a graphics context to hold rendering information for the Wimp. No. Pointer to graphics structure or null failed. Okay. And then we can copy that into the C file, which is just over here now. And we also want to copy from the types this Wimp Graphics object, because we're not putting it in there anymore, it's in here. And we'll include types in there. Okay. Which will probably mean that other parts of the code will now be broken. Yep, CMain is now broken. We need to include. Oh, that's also because it's not even got a valid code in there. Wimp graphics.h. Graphics equals Wimp graphics. Create. Build. Null, sorry. Printf. Not enough memory. How to initialize. Exit 1. Right. Are we going to be able to get somewhere where we can actually create this sprite? And inventing, what's that, sorry? Inventing Wimp Sprite. Oh, we haven't included it then. That's also a pointer it's meant to be, isn't it? And that's meant to be in Wimp Sprite. Now where do we get to? Right, looking better. Let's go add it into here. Well, that didn't work. Oh no, I didn't mean make. Sorry, I meant you've got to make as riscos, otherwise it ends up getting all confused. Right, Wimp graphics. Oh, I've not included its own header. That's why. There we go. That probably will work now. Still unhappy. Doesn't know calc. Okay, studlib. What else? Null is in studlib as well. Pointers, an error. Oh, I haven't got an error defined somewhere, so let's go define that. Let's put it in here. Kernel os error start. Okay, build again. I think I've got some variables that I've misused there. Yeah, two of them, 51 and 52. Yeah, because I need to use that. And there. There we go. That should allow it to work. Now, let's just clean it. Let's go to ammo clean and then rebuild it, just to be sure that we've really got it clean, because we haven't got any proper dependencies on this, and almost certainly, yeah, we've broken something. Wimp Sprite has no members because Wimp graphics couldn't be created. So, in h.wimpsprite, so that needs to include Wimp graphics. Okay, build that. Pyro dev common. There's our command. We found this. Okay, we didn't print anything else out. We didn't actually do anything else with it. But let's see if we declare but not used. Correct. Created a Wimp Sprite. Just check that that actually came out with something. Yep, that's doing that. And this one, we got an object. That seems good. So, Wimp Sprite render. Position 640, 480. I can't remember what the other parameters are for it. What do we need? What do we need? Render XY and then whether it's tiled or not. So we don't want it tiled. There we go. That's the entire call. Right. It's built it. All right. So all this, we'll put it into WX widgets so we get the screen up. And yeah, we kind of need to stop at the end, don't we? How about we stick in a command GOS at the end, just so we stop. There's a distinct lack of anything being plotted there, isn't there? I suspect that's because none of our color trans calls actually did anything. We probably also want to include a little bit of debug to find out whether any of the other calls failed. So let's do some in here. So we haven't got any in this at the moment. So define debug. Oh, defing. Defings we are doing are degrade. No, no, I can't do that. If no def debug. Oh no, def debug. Define. Ooh, sorry. Oh, now I'm getting a bit sleepy. What is it? 3 o'clock. All right. That's not terrible. All right. And then we'll put some debug in here and see what we get. Oh, this is a header file. See, proves how sleepy I am. I'm looking at completely the wrong file. Sprites. So, rendering code. Let's see what we get here. We can print out whether it rendered or not. So, sprite underscore render of sprite at that address at action right. So what we got here, we got sprite x0, y0, action is plot action, and then finally we want to say question mark mess, otherwise no error, like that. Build, run. No error. That's kind of interesting, given that it now did nothing, though. I suspect that means that because we've got no color trans calls in there, it isn't actually doing anything. So let's create some color trans, shall we? Color trans. Right, that's a header. Color trans operations underscore color trans right, and then we know what the functions are going to be because they're stubbed in here. Stubby. Copy them out of there, put them in here, and then just comment them, and then the same goes here. Oops. Right, that's our stub routine, our prototypes. Now we need to go and duplicate this file to see. Come on, there you go, thank you. And then we want to start including some things. So we want to include something. Swise.h certainly, and we're definitely going to need studint.h because we're using them in here. In fact, studint.h should actually be included in the color trans file because it's using it in the header. And we should of course include ourselves in here as well. Bum, 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 bum. Righty, we've got get table size and we've got generate table. So these are two very similar routines, as we know. Literally Swix color trans and generate table. No, I don't remember. Look it up. Thank you. That was not the operation I wanted. Generate table. Okay, there we are. Right, source mode. Oh, you know what we'll do? Same thing we did before. Copy the lot. And then we'll stick them in here. So 0 to 7 is the parameters we want in here. And we get back, oh, I didn't copy the ones, it's in R4. Out and 4. So we're going to need a kernel os error to return the error in. And we're going to need the, this is the size of the buffer. Size required. So source mode. Source mode. Source palette. Destination mode. Destination palette. Do not even begin to worry about these because they're complicated as heck. I'm dreading having to implement these in C for color trans. Hopefully I'll be able to convert it from the code in Pyromaniac, but it's nasty. So that's 0, 1, 2, 3. Yeah. Pointer to the buffer. We want 0, which is get return size of buffer. And then this one here is flags, which is R1 is a pointer to a sprite, which it isn't. It's neither, in fact. Palette pointer. I don't think we're actually doing anything there. Current palette, or if sprite doesn't have one, otherwise use the default. R6 and R7 are transfer functions. So actually I'm not sure, because if the transfer functions were supplied, oh yeah, we don't actually specify them there anyway. And then pixel translation table or whatever. Yeah, so there we go. 0, and that's it. That's all our parameters we've actually supplied. So 6 and 7 can be 0. Sorry, I got that wrong. 0, 1, 2, 3, 4, 5, 6, 7. If that's flags, I should probably put in flags there, shouldn't I? And we should be assigning this to like that. And of course we want to return this into size required. If return -1. And then what else do we do here? Oh, we just return the size, don't we? Size required. Yep. There we go. Now, same interface, but with more magic. So we may as well just copy the whole blooming thing and fill in extra values. Oh, apparently we're returning bool here, which is for success or failure. That's not too bad. Well, maybe I should return an error, and then we can actually know what went wrong. Not sure. Source and dest, output buffer, output, yeah, flags, and then the color map. And color map workspace. There we are. We don't need the size returning for this one, so we actually take that out. And then we can do if return false, otherwise return true. And that means we don't need the size request either. And this is a C file, so we don't need that. And then we can take out all of our information. Whoa, this is quite bizarre, isn't it? It's actually been implementing things. Whether it'll work, who knows? Color trans get table size. Read the size of a color trans. So pixel translation table for a translation. Source mode. Mode to convert from, or -1 for current mode. Palette. It's like brain's just source palette. Palette to use or pointer to sprite. Or -1 for current palette. There's a nasty table that deals with all of this. Mode to convert to or 256 for sprite pointer. There we go. And then this one is the same, but dest. Ugh, horrible thing. Really is horrible. Right, sorry, anyway, output flags. Flags for the conversion. Size of table required, or -1 if anything went. And arguably we should be returning the error pointer there instead, but I'm trying to keep these as simple and C-ish as possible. It's a nice day today. Well, I'd like to try and go outside, but I think it's both myself and Telly are exhausted at the minute. Translation table into the output buffer. I've also got some articles I want to write as well, which I haven't got around to doing yet, and they're quite. They need a bit of brain being applied to them, which I'm not good at. Links to the buffer to write to flags and flags for the conversion, and then we've got the color map functions. So color. I wonder why I didn't use a color map descriptor there. Oh, because this was already predefined, wasn't it? Okay, and then finally returns true if generated, false if failed. All good. Right, we've now got some words there, so copy that into the header. Oop, missed. And copy same one from here into the header as well. Right, now these are all defined, but we're going to need to include them from somewhere. So we probably need to include them from here, because those two need to go. We do include color transform. There we are. Yeah, that's right. Riscos ammo and not put it into the make file. Stud bool's missing. In fact, stud bool should even be in here, shouldn't it? Because we're using it. Here we go. Can we get something out? Something working? Anything? Well, what do you know? We have a sprite. In fact, let's see if we can get a bit nicer and change to a different mode. Config view.mode, mode 28. Actually, mode 32. Why not? We have a nice text icon plotted. Nice, huh? So now that that works, let's go back to our main function and let's do this with some flags. So I've forgotten which ones these are. I need to find what the thing is. It's half size, unscaled, selected is shaded. Okay. So you know what I'm going to do? I'm going to put these in here. And we can put that there. Maybe that wasn't quite so useful. And then we'll construct what they should be. Right, so is half size equals index and 1. Is unscaled equals index. False. Never do that one. Index and 2. And then is shaded index and 4. Okay. And then the position we're going to plot them at is going to be also dependent on that. So index, so 640 plus, let's say 96 times index and 3. And this one equals plus 96 times index, minus, so I want it to go down the screen, index and 4 divided by 4. I could shift right 2, couldn't I? Shift right 2 would be more sensible, wouldn't it? Yeah. Okay, and then we can put a loop around this for I. No, how do you write loops in C? Oh dear. I is less than 7, I plus plus. There we go. I need to define the integer I. Build it. $52. Oh, Mr. Bracket, that's why. In fact, it's telling me there I missed a bracket. Build it again. Nope, good. Run it. Watch it go bang now. Yay! So, oh, except the last one didn't draw. Oh, because I told it less than, I meant to say less than 8, didn't I? So the half size icons are working. That's cool. We don't have shaded and we don't have selected yet. And the reason for that is that we just haven't implemented those calls. But we do have the other bits, which is cool. So what I want to do now is just, come on, just get me out of this. Thank you. Commit that into 8. I can commit this code. We're doing that as well. Yeah, fine. Status and C and H. Add simple color trans operations and test. Now, oh, I just remembered. Have the color trans pixel translation tables generated. There we go. Right, I've just remembered that when I did this, not there, please. I want it to go to this monitor, please. It gave me an error. It failed on the last build. What failed? Well, I got a mail through that told me it failed. Oh, Sprite doesn't exist in the Sprite pool. Correct, it doesn't, because we haven't loaded it. So we need to update Riscos build. We need to tell it to go and do, to test it. We actually need to do it here, don't we? So start icon, sprites, sprites 2.2. There we go. There we are. Should be all we need, I think. Do we need to make sure we're sending it to that? Yeah, you can. Just half an hour gap for this. Thank you very much. Right. Sorry, what was I doing? I was just checking whether how we were sending it, because if we're sending all the files, then that's good. Yeah, we're sending all files, so it's going to work. That's fine. Actually, we probably shouldn't be sending all the files. We should probably just send the ones we need, but that's also fine. Status. Ensure that we start icon sprites, the pool, the sprites for the pool. And push. And now we'll have a look and see whether this time it's working. Got Python 3 problems in that. That's annoying. There we go. Look, it rendered things. I mean, we don't get them back, but it rendered them. We could potentially get them back, actually, couldn't we? Cool. All right. That's now doing things. So what have we got implemented? We've only implemented the stubs for the Wimp graphics. We've implemented half size, but not selected or shaded or highlighted either, for that matter. Don't think we actually do anything for highlighted, but selected and shaded we should do something with. There's a few little bits we need to juggle with to get that working. And unscaled should work, but we haven't actually tested it yet. How would we test that? We could test it by, actually I could test that, yeah. So 1, 2, that's 4 different combinations. That's 16 different things, isn't it? So if I do use that, and we do this as I and 2, this becomes 4 and this becomes 8, and then we make it go through all 16 versions, I think it's going to be just fine. But if I put it in, say, mode 13 instead, you'll see something very different. Let's have a see. Okay, that wasn't quite so helpful. I probably need it to not print out quite so much. Let's put these into debug mode there, and then we'll go and pinch the bit of, oh, it's not in there. Okay, this one, yeah, this one. Oh, and I probably want to comment that out as well, don't I? We don't actually want any debug in there. Main debug, we'll comment that out. Oh, I haven't got Studio defined in one of them. 96 isn't quite big enough. Let's move things around a bit, shall we? How do we move them around? So we want this as maybe, we put this as 128. 96 is not enough to make it 128 there, and probably 128 there as well. Oh, and then our numbers are wrong. Oh, no, that's right. Our numbers are right. Yeah. See that. Yeah. So if we, it's appeared on the wrong screen, I'm afraid. There we go. It's better. Right. So this one, this bit here is 0, 1. So those two are, that's the half size bits. Half size, half size. Unscaled and half size means nothing. So those two are the same. Unscaled means it's doing it as 1 pixel to 1 pixel. Is that really right? Oh, it is. Yes, that's right. It just ends up looking a bit strange. Yeah, because this is a 1-1 mode. If I remember rightly. Mode 13 is 1-1. 2-1. I don't know what it is actually. What is mode 13? Riscos. Mode 13. Screen modes, that's what I want to know. Mode 13 is... Why are you not telling me the pixel shape? It's not very helpful. That's really unhelpful. Okay. Sorry, modes.py. Modes. No, that's the wrong sort of mode. That's processor mode. Mode.py. VDU mode. That's more like it. And that's got mode defines the modes, and yeah, fine. Oh, lovely. Lots of configuration items, and then here's our mode table. Right. Mode 13 is 320 by 256, and it's a 2:2 mode. That's right. So that's why the dimension, it still comes out square, but it's lost half its pixels, a quarter of its pixels actually, 3/4 of its pixels. Yeah, so that's actually worked, I feel. Right, so the next bit is going to be getting shading and what's the other one? I've forgotten already. Selected and shading to work, which is not hard. Come on, thank you. It's not hard, but it does mean an extra thing. Right, commit manager. Do we change? Oh, this is debug, yeah. Commit manager. Ensure that we step through all the options. Okay, so we've now got that there. I think because we've got something on the screen and working, I'm gonna call it a day there, and then next week we will have a look at the fun that is going to be the selection and shading, because they're not difficult, they just need a bit of thought. And it's not something I can really do in about half an hour. It's just not really with it for that. So I think that's what we'll do. Yeah, I think we've got quite a good thing here. What I will need to do is I will pick up some of this and I'll start migrating some parts of this into how it should be handled inside the G context. Because if we can do it in G context, the actual sprite operations and the like, then it would be just as easy for us to do things to the screen as to a draw file or something else in the future. That's the goal of Gcontext, to sort of abstract that interface. So right now I think it's not doing very much, but we will be able to do that. Yeah, I think we're done quite well there. I would normally go and update the status, wouldn't I? With 64 status. Let's have a quick see. Did I even create anything for this? For features Wimp. Okay, WindowManager. Sprite Pool, Sprite Render. I've only got the MMD file. That's frustrating, isn't it? Oh, I suppose we could do something with that. Just drop to the bottom. Here we go. All of the different components here, so many bits. And I need to fix the rendering because it's just ugly. Ugly. Viscos 64 status. I mean, look at this. Look at the colouring on this. I mean, it's just there. I'm going to need to create a PNG or something and then embed it, which is just so tacky. Really didn't want to do that. But we can cope. We will be able to do this. Yeah, so what I want is, this is the WindowManager. Duplicate this to Sprite Render, that's right, yeah. Right. So, this is the Wimp, yeah, okay. We don't do that, we don't do that. We may do services. We don't have SWIs. Well, I guess we do have SWIs, but not a display. We do a graphics output, and we'll probably use a heat direct area. We always message trans, right? Functionality. Right. So, what things do we need to be able to do? We need to be able to render the 16 different combinations. Render half size. We need to be able to render shaded. We need to be able to render shaded selected as well. And then we need to put the two together. We're going to assume that half size works for that. And I'm going to ignore the unscaled because that's not a big deal right now. We're going to be able to need to size the icons, size the sprites, current mode. What else are we needing to do? We need to render with color mapping for high depths. What are the other things it needs? Clipping to render clipped to graphics window. Anything else we need? Don't know. No commands. Still none. None in there. Oh, actually, no, because icon sprites is going to handle elsewhere. Yeah, those are handled in the sprite pool handling. And this actually, we don't do any of this either. We don't actually do any SWIs because all the sprites are actually, all the rendering is all done through plot icon. We may need to handle mode change and switching output to sprite, but that's probably about it. Vectors, nope, we don't handle any of them. No. We definitely don't need any events on here. The rest of the Wimp might, but we don't. And do we issue any services? No, because that's handled by the sprite pool. And we don't issue any vector calls either. We do call out to color map, color trans, not to font manager. That's all we'll need to call out to, I think. Yeah, we don't even need blend table, I don't think. Yeah, because blend table is used for rendering. So that should be about it. What do we manage to do so far? We've got rendering half sizes working. We saw that. Can we size them? Not proven yet. I mean, I'm assuming it works, but it's not proven. Can't do. I haven't checked for the columns. Nope. That's the only thing we've managed to do so far. So that's what we've got. We may need to expand this as we move on, but I think that is a true reflection of where we are with sprite rendering. And can we define, say it's any further on this? So we have a look at the Wimp Sprite Render. Okay, it is definitely beyond. So if we have a look at the actual stages over here, it's beyond investigate. We've definitely got a stub done, so that's good. Prototype is meant for like hardware things. Build is meant for things that are done elsewhere, have previously been made work, and we've got them built. Internals, it's not completely done with the internals, I don't think. So I think we can get as far as saying this is a stub. So let's put it as stub for both. Actually, let's give it a quick test in 64-bit, shall we? Viscous ammo, build 64 equals 1. Oh, yeah, that's not going to work. Viscous ammo, build 64 equals 1. And we'll try it in 64-bit and just confirm that it works. I've missed Studio in sprite.c. Okay. Let's just tweak that. Right, rebuild that just to get those things quieted. Much better. Yeah, I know we've cast things that we shouldn't have done. Sorry about that. Yeah, that's right. Okay, so we've done that. Now we just want to go and run it. Oh, should have done it in here, shouldn't I? Build 64 equals 1, and then run it as 64-bit. Oh, yeah, and run the 64-bit binary, not the 32-bit one. That looks like it's working to me. Pretty cool. Okay, and that also means that the half size is working as well, so we can tick that off. So we definitely have stub for both of this. Stub there. And if we go back to this, we can tick off render at half size as well, which is pretty cool. Right, so diff that. Small fix for includes of studio. Push, and then we can go update here as well. Ooh, we need to add the other file as well, don't we? Git add that, because that's new. Get the basics of the Wimp Sprite Rendering working. Okay. And then we can push that, and if we are lucky, so it's not in here, is it? It's not in this one. It's in one of the others. So if we look in, just look in the wiki. 22%, 8%. Don't know which one it's in. Not in here. Must be in stage 3 then. 8% it says. Sprite rendering here. So sprite rendering. Look, we've got 2 ticks. Whee! So need to fix this. It looks ugly. And that gives us 8%. If I reload it, yeah, didn't change from 8%. That's disappointing, isn't it? Oh well. Fair enough. Can't believe you got sprites working on the screen so quickly. It took me longer than I was expecting, really. But remember, a lot of this is the work we did before that set it up. Sprites are very easy, really, once you've got the pattern of how you do things. Getting that pattern is hard, and we haven't tested deep modes yet, and we haven't tested deep sprites. And obviously we haven't done any of the colour mapping either, so we've still got quite a bit to go with. But yeah, as you can see, they're working. Right, I will call it a day there. Thank you very much for watching. Thanks for the compliment at the very least, Alan. That's very nice. I'm glad we managed to get to the point where it's got something on the screen. Next week we will look at, what are we going to look at? We're going to look at the shaded, selected, shading selected, and start looking at the color mapping, because it's going to be part of the same process. It'll be fun. It'll be kind of fun. Yeah. All right. See you next week. Have a good Sunday. And yeah, if you want to subscribe, feel free. If you've got a real feel that you want to contribute, have a look at the code and see if you can add something, create a PR or whatever. Or if you can't do that, there's always the sponsorship. Yeah, thank you very much. Yes, see you all later. See if I can press the right buttons now. Bing.